Today's lesson on dilations is part of our unit on rate, ratio, and proportion. We're going to be able to identify and create dilations of plane figures. You need to know the definition for dilation, what a center of dilation and a scale factor are. We'll go through that during the lesson. Right now, I'd like you to pause just to make sure you understand what similar figures are and answer each of the following three questions. This will give you a chance to work on your cross products, understand similar figures, and how the plane figures relate to each other. Okay, welcome back. Let's check how you did. A rectangular house is 32 feet wide and 68 feet long, and on the blueprint the width is 8 inches. Find the length on the blueprint. So here are the answers for a variety of so it's 17 inches long on the blueprint. The photo in the poster, the tall poster is now 3 3/4 feet tall. And rectangle A and B are similar to each other. So let's work with dilations. Your pupils are the black areas in the center of your eye. And when you go to the eye doctor, the doctor might dilate your eye, and that makes them larger, the pupils. Because a dilation is a transformation that changes the size but not the shape of the figure. If you remember what we did in our lesson on similar figures, a circle is always similar to another circle because it has the same size, although the shape might not be the same. And when you have different types of transformations, before we've studied rotations, reflections, and translations, this is another kind of transformation. It changes the size, but not the shape of the figure. Every dilation has a fixed point that's called the center of dilation. And to figure out what that center is, you can draw a line to connect each of the corresponding angles or vertices of the figure and see where they meet up. If you notice, right here is where that meets up on this particular figure. So see, here is our original figure, here's our dilation, and this red dot is our center of dilation. We can figure out if a transformation is a dilation by using that idea of similar figures. So if you notice my original figure here, BC, AC, this is the dilation because this is the A prime, B prime, C prime, D prime. Here's my original figure, A, B, C, and D. And we can check to see if these side lengths are each 2 and these side lengths are each 6, the angles are corresponding, the sides correspond, the ratios are the same. So yes, they are in fact a dilation. And with a square or a circle, clearly that would be the case. To determine whether or not this shape is a transformation or a dilation type of transformation, we have to do the same idea. So our original figure here is the larger one, ABC. And is this dilation? And in this case, it's a shrink because one type of dilation is a shrink, the other type is an enlarge. If we go back, this one is an enlargement, this one is a shrink potentially. So we have to check and see, is AB in our dilation proportional to AB in the original figure the same way AC is in proportion to AC here? So we have to check that out. So we're going to use that idea of a similar figure, and we're going to create that ratio again. BA is 4, BA is 2, AC is 5, AC is 3. Now, these are not in proportion. Those ratios of the corresponding side lengths are not equal. So these are not similar figures, which means it's not a dilation. A scale factor describes how much a figure does get enlarged or reduced. It represents the ratio of the length of the image to the corresponding length on the original figure. So if we look here, we can use the origin as a center of dilation or other parts of the shape. So if you want to dilate a figure by a scale factor of 2, that means every point, every coordinate gets multiplied by 2. So if you can see, here's my original ordered pair, 2, 2. I multiply both the x and the y in the ordered pair by 2, and my new point is at 4, 4. My original at 3, 4, I'm multiplying each part of the ordered pair by 2 to get 6, 8. Same thing with 5, 2. Multiply each by 2 and get 10, 4. And here's the new figure. It's dilated. It's definitely enlarged because of a scale factor of 2. So when we want to do a scale factor of a third, we can figure out the vertices of the image. So here's our original figure, ABC. When you're trying to do a scale factor and dilate a figure, the first thing you need to do is write down the ordered pairs for A, B, and C. So make sure on this slide that you pause for a moment and follow these steps one by one. First, you're going to write the ordered pairs for A, B, and C. Then you're going to multiply each coordinate in the ordered pair by the scale factor, in this case 1/3. Then you're going to create new ordered pairs for A, B, and C, and you can draw both images. Please take a moment to do that in your notes. Okay, welcome back. Let's see what you have. Hopefully your shape looks something like this. If we are dilating from the origin, we have a shrink. If you notice the 1/3, the blue is our shrunken triangle here. And we can do that with this as well. I'm going to try and write the ordered pairs, multiply each coordinate in the ordered pair by the scale factor, create new ordered pairs, and then draw both images. And this time with the scale factor of 2, as you can imagine, it's going to be larger. You should get something that looks like these are our new ordered pairs. So if we're dilating by a scale factor of 0.5, again, that's going to be shrinking the shape. Take a moment to do that, and we're going to come back and check our work. There you go. We have our different scale factors here, our new ordered pairs. Now that you have the ordered pairs and you've learned how to transform by dilation, a place that you might see this in practice is maybe Minecraft or other video games. Because when you're dilating, you're also creating a way that you can have a horizon line and a vision point where, if you notice, this is a 3-dimensional scale. So see how this shape is dilated. If I just had this line is dilated, it's a dilation of this line. And this line is a dilation of this line. It's all parallel. They're similar if you're talking just lines, and this is how we create a 3-dimensional shape. So I look forward to working with you on dilations, and I hope you have a great day.